Hey guys, welcome. Let's go ahead and get started. We are doing 2.4. This is called Deductive Reasoning, and our objective is to use the law of detachment and the law of syllogism. So we're continually adding to our repertoire of reasoning skills. We've talked about inductive reasoning, where we reason by looking at observations, and today we're going to be talking about deductive reasoning and two forms, which would be law of detachment and law of syllogism. So let's go ahead and try two of these out. If I can scroll down, I will make it. Okay, hold on. Oh gosh. Okay, sorry about that. First of all, we have deductive reasoning. So let's go ahead and write this down. You use deductive reasoning when? Deductive reasoning, sometimes called logical reasoning, is the process of reasoning logically from given statements or facts. We're not observing anything, we're given facts and we're going to make a conclusion from it. So go ahead and copy all of this down. I don't know why I chose to use red, that's kind of confusing, but you want to copy down that definition. Also, go ahead and copy this box down. One of our types of deductive reasoning is called law of detachment, where we can actually go ahead and figure out if something's true. So, looking at the law of detachment, if the hypothesis of a true conditional, this is a true conditional, is true, then the conclusion is true. So P, then Q, if that's true statement, then P is true and Q is true. So the reason why we call it law of detachment is the conclusion and the hypothesis and the conclusion are together, and if together they're true, then detached they're also true, okay, by themselves. So if together they're true, then we would say detached they're also true. Okay, let's take a look at the second type of deductive reasoning we have, which is called, not on this page, which is called the law of syllogism. Syllogism is how you say that. It's kind of interesting. But the law of syllogism, so go ahead and write this down. The law of syllogism allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. So write that down and write this box down as well. Basically, if P then Q is true, and Q then R is true, then P is R is true. Confusing? Yes, I know. Here's an example. If it's July, then you're on summer vacation. If you're on summer vacation, then you work at a smoothie shop. So it's July, so you work at a smoothie shop. All right, 1 second, I'll be right back. Okay, I'm back. Let me show you what I mean by this using action figures. Here we go. Luke Skywalker, Poe Dameron, and Finn. Okay? So we got three of them. Alright, so this is what I'm going to say. We're going to use law of syllogism to show this is true. Okay? We're going to start out with these two. Okay? Luke is the same height as Poe. Okay? So Luke is the same height as Poe. Poe is the same height as Finn. Poe is the same height as Finn. So those are two conditional statements I gave you. From those two statements, we then get, drum roll please, a conclusion that Luke must be the same height as Finn. Okay? So what we are basically doing is we're saying, hey, look at Luke and Poe, they're the same height. Poe and Finn, they're the same height. Thus, our conclusion is Finn and Luke are the same height, right? This is the law of syllogism. It's just saying this, then this, that, then that, makes a connection between the two, okay? If you look here in the picture, P and Q, Q and R, never did we have a relationship between P and R. But through the law of syllogism, through deductive reasoning, we say there must be a relationship between P and R. Okay? Let's look at an example. Okay, here's our first example, 1. Boom, boom. What can you conclude from the given statement? If a student gets an A on exam, then the student will pass the course. Okay? Felicia got an A on her exam. All right, so law of detachment, so it basically says this is a true, so it's a given true statement. So if this is true, okay, we have two different pieces. We have if the student gets an A on the final exam, we'll call that the hypothesis, P, and then the student will pass the course. I did not do that in the right color, my bad. Let me get that correct. Then the student will pass the course, that's my hypothesis, and we call it Q. Looks kind of like an 8 right there. Okay, so Felicia got an A on her exam, that's the P, so what must be true? Yellow's going to be too hard to see, so Felicia got an A, so what's true? She will pass the course. Okay? Hard to write that for some reason, but yeah. So, hypothesis is true, thus the conclusion must be true. Let's look at one more. This one I don't want you to write down. Okay, so follow this one along with me. What can we conclude from the given information? If there's lightning, then it's not safe to be out in the open. Maria sees lightning from the soccer field. Then it's not safe to be outside. So if lightning, that's a hypothesis. Conclusion, not safe outside. She sees lightning, so we say the hypothesis is true. That means the conclusion must also be true. It's not safe to go outside. Okay? So if the hypothesis and conclusion are true conditionals, if we give the hypothesis, then the conclusion is also true. All right, let's look at law of syllogism. Okay, number 2, we're going to write this one down. If a figure is a square, then the figure is a rectangle. If the figure is a rectangle, then the figure has 4 sides. Okay, so what I like to do is give these letters P, Q, and R. The first statement I see, the figure is a square, I'm going to write as P. Next, the figure is a rectangle. So if it's a square, then it's a rectangle. This is going to be my Q. If the figure is a rectangle, see how it gets repeated again? Then it has 4 sides. So we'll use that as a different color. Let's go green. And we'll call that R. Okay? So P, if it's a square, then it's a rectangle. If it's a rectangle, then it has 4 sides. So what's the logical conclusion? We can connect the P and the Q together. Okay? So what we can say is we can say, then, if a square then, now we can connect it with the R, then the figure has 4, that's a 4, sides. Okay? So again, P then Q, Q then R. What's our conclusion? P then R. Okay, one more time. Luke is the same height as Poe. Poe is the same height as Finn. What's my conclusion? Luke and Finn have the same height. Okay? That's it. We just got to practice. So let's get to practicing. And when I say practice, I would like you to come to school with the answer to this problem here. So if you can. If a number ends in 0, then it's divisible by 10. If a number is divisible by 10, then it's divisible by 5. So go ahead and see if you can come up with the conclusion to this. All right.